The purpose of this video tutorial is to show how to set up support lines for the generation of design strips and how to model tendons using both manual and automated input for Adapt Floor Pro 2010. In this example, we're going to set up the X and the Y direction support lines, followed by generation of design sections, and finally the tendon input mapped to the support lines as well as manual input. The first thing we're going to do is generate the X direction support lines. So using the modeling toolbar, we'll go to Create Support Line, and we're going to make sure we have the snapping components turned on. We're going to go ahead and undock that toolbar and bring it down into the main screen. And we're going to start at the slab edge and work our way left to right for each of the support lines. So using Snap to Nearest, we'll go ahead and start at this slab edge, snap to the end point of the wall, we'll snap to the next end point of the wall, and work our way to the right side of the screen. Now this wall stops at this location. We'll press C to close off that support line, and we'll start our new support line at this wall and snap to the end. Working our way top to bottom, we'll do the same in a systematic fashion. And we'll go to column, snapping on the center of columns. Here we'll go down to this wall in the X direction, snap to the end point, and then we'll use the snap to perpendicular to close off the support line. For this wall, we're going to just use the support line over the top of the wall, and then starting on the column line down, we're going to again go snap to nearest. We'll snap perpendicular to the center of this longitudinal wall in the Y direction, and again we'll go center to center to columns, endpoint to wall, opposite endpoint, back to the column, and then snap to perpendicular to close off the support line. It's good practice to save the file every so often, and we'll continue working our way down the slab in the X direction. Now each distance between 2 points on a support line is referred to as a span, which dictates the number of design sections that will be, or the density of design sections along the support line. So it's important, if you have different span lengths, we may need to adjust the number of design sections for each of the different support lines. So we'll wait until we generate the sections before we begin doing that. Another option where we have fairly well-defined design strips is to use the support line wizard. Here we're going to again select the X direction. We have our bandwidth to detect supports. This is the width for which the wizard will scan for supports. We'll say OK, and we'll click on 2 points that dictate the band that's going to be scanning, and we'll say yes. We'll go down to the next line, and then finally this line, and we're going to go ahead and exit. And you can see that the program will automatically detect supports and create points for those support lines. At the bottom of the slab, we're going to do manual input again. So we have already selected the X direction. We want to make sure that's selected again. We'll go snap to endpoint. And again, similar to the top of the slab, we're going to terminate that there. And it's important to snap to the endpoints of beams so that the beam is considered as part of a design section. And so we'll snap the opposite beam endpoint, the far end wall endpoint, and then snap to perpendicular to close off the support line. And these are now our X direction support lines. If we have Anytime we have a support line that terminates inside of a slab region, we want to use a splitter in order to bound off that support line. So the splitter needs to be designated as the same direction as the support line. Here we're going to designate this as X direction. Even though it might be oriented in the Y direction, it still influences the X direction. So we want to make sure that it's in the proper direction as far as the description goes in the property box. And we're going to go to the support lines that terminate outside, or I should say inside of a slab region, and we're going to start at those endpoints and work our way down to the adjacent support lines in order to close those off. And we also need to add a support line here along this wall on the interior of the slab near this opening. So we want to go ahead and we're going to need to use splitters in this case as well. We have all of our input for the X direction support lines and splitters, and I want to review the generation of the tributary regions. So I'll go to strips, generate design strips for FEM, and if I use the report plans toolbar, I want to generate the design strips in the X direction. I'll just select OK, and this will show me a hatched view of the support lines in this direction. So these support lines look sufficient. We'll go ahead and exit that view, and now we want to go ahead and enter the Y direction support line. Since it's a two-way slab, we need representative design strips in both directions. I'll select the option to generate support lines again from the modeling toolbar. I want to change this now to Y direction for the property box, and I'll begin over on the left hand side and work my way left to right. It's a good thing to have some standard with how you're inputting different components. So I always work left to right, bottom to top for generation of tendons and also support lines. We'll select again snap to nearest. You'll find that you're going to use the snapping toolbar, and you'll get used to using these different icons in generating these support lines. Now in this location we have this is almost equidistant from this point to the edge of the wall and this point to this column. So the support line here might be a Y shape. We might also have a support line that starts here and terminates in that location at the slab edge. I'm going to snap to all of these columns here. I missed the column center, but that's okay. We can go ahead back and fix that. We'll just select the support line, select this point, and just snap back to the center of the column. On this wall extends outside of the slab region. So because we're going to be mapping tendons to this support line, I'm going to select the slab edge to stop this, and I'll just go to the end point of the wall, and then I'll start into my column line. If we were to start at the end point of that wall, then the wall itself, or the tendon that's mapped, would actually extend outside of the slab. That would cause a warning and something that we would just simply need to go back and fix in the design section, or in the tendon generation box. turn back, snap to nearest. Made a mistake there, so I just need to go back and reselect the input of the support lines. And again, we have support lines that stop inside of a slab region, so we're going to use the splitter option again. This time we're going to change this to Y direction. The first support line that terminates is in this left-hand side, this portion that extends outside of the main envelope of the slab. So we'll make sure that we select the endpoint, snap perpendicular to the opposite support lines. We have another one here that would snap over to this support line and then again over to the opposite side. And we also have this support line that goes off to the right up to this column, so we want to go ahead and generate a support line, or a splitter I should say, that begins there and again goes to the adjacent support lines. We don't need those two spans on that splitter, so we'll just go back and redo that to this point. And then finally on the right hand side, we can close this right off on the slab edge. We'll save the model, and again we're going to generate the design strips. We generated those for the strip method, so we get warnings here. We need to go back and generate these for FEM, since we're going to be running all the tendon input and design inside of Floor Pro. And again, from the Report Plans toolbar, we'll review the Y direction, and we can see the defined tributary regions for each of the support lines. So the support lines look correct. We'll go ahead and exit that. The next thing we're going to do is we're going to generate the design sections. So if I go to FEM, generate design sections automatically, I'm going to go to select set view items, and I'm going to isolate the Y or the X direction. And you can see that the spans that are longer have a less dense distribution of design sections. So if we want to modify that, we can double click on any of these support lines. We can go to design section options, and instead of using 12, I'll use 25. And this will apply to each span for this support line selected. Now there is a default value for the distance between design sections. If the division that you've input in the support line property box results in design sections that are closer spaced than the default value, the program is going to default back to that value. So for example, for this support line I have a long span with fairly wide spacing that goes into shorter spans with closer spacing. So when I enter 25, I'm trying to change the spacing of this span, and due to the default value or the threshold, the distribution in the spans to the right of this will essentially remain the same or remain close to the distribution here. If we go back to FEM, generate design sections, you can see now that the distribution for this first span and the remainder of the spans is close to the same. So we'll toggle between we're going to toggle between both directions using the display design sections, and we can see that the Y direction also has a few areas where we're going to increase that design section count. So I'll change these to 25 as well. This is essentially giving me more data points in the slab or representative design sections. And it's telling me I have one support line with less than 2 design sections, so we could isolate that. If we find that support line, we can determine which one that is and change that. If I go to select by type, support line, keyword 13, it should find the support line using this option. So we may need to put in support line 13, or we could simply go to select by type. We can turn on the ID of each of the support lines, or I'm sorry, the label of the support lines, and determine where support line 13 is. So support line 13 is out on the edge. It's a very short support line. If I was to try to increase the count on this support line, the threshold is likely going to control, and we're not going to get any more than two or three valid design sections in that support line anyway. So because of the length of the support line. So we'll simply ignore that in this model, and we'll just continue on with determining the tendons for each of the directions. At this point, if we were to run the analysis and the design, all of the sections would be designed as reinforced concrete sections of a conventional nature because we have no tendons input into the slab. But we want to go ahead and input the tendons. So there's two ways to input tendons. We can map the tendons to the support lines that have been generated, or we can manually input the tendons based on some educated guess of what the tendon should be, or just simply determining manually what the pre-compression is, what we want it to be, and how many tendons we would need to meet that force required for pre-compression. So we're going to go ahead and map the banded tendons first. The banded tendons are going to be along this support line and this support line in the X direction. We're also going to input some straight tendons out along the perimeter of these walls just to provide some pre-compression in that region. We'll start with this support line. I want to go ahead and use the Map Banded Tendon tool. We're going to use the tributary region for the design strip width, so we'll select this option, and it will use the tributary for each of these sections to envelope a force that it's going to calculate. The minimum pre-compression will leave between 125 and 250. The percent of the self-weight to balance we're going to say is 50 to 100%. The placement means that the program will place one tendon on each side of the support line with equal number of strands. So we're going to say that that's going to be 2 feet to either side. And then we're going to assume an effective force of 26.7 kips. If you want to use calculated force after the program has determined the starting point based on this partial optimization, you can change the tendon that the program has calculated in input from force method to calculated force method. Thereby the program would calculate friction loss, seating loss, and then you would enter some lump sum value for long-term loss. The first span we're going to say is a cantilever down shape. The last span is cantilever down, and all of the interior spans along the support line will be reverse parabolic with these inflection point distances. We'll say OK, and the program maps two banded tendons to this support line, and note that the banded tendons are parallel with the support line. So there's a few things that we're going to have to fix. Because the support line extends all the way to the slab edge, one of the tendons, the one on the top, extends beyond the face of the slab. So this is a problem, and we need to correct it in the model. What I'll do is I'll double click on this support line, and I'm just going to go to Shape and System Friction for the tendon input. I want to go to first span, and I'll delete the first span. The program will tell me that the tendon is outside of the slab, so if I come back to this tendon, it's still outside of this slab. We'll delete that again, and again the tendon's outside of the slab on the opposite end as well. So there's two spans. There's a short span and then a longer span. That's why we have to delete this twice. So if I go to last span, I'll delete that, and I'll delete it again. The tendon is now inside of the slab, so we could take that and stretch it to the slab edge, or we can go and select this tendon and use this extend tendon or trim tendon option, and that will stretch it outside to the slab edge. Going back to my Shape System Friction, I want to anchor these at the center of the slab. In this case, the slab dimension is 12 inches. So I'll enter 12 divided by 2, which is 6, at the center of the slab on both ends. Notice that this is now 6 3/4 CGS from the bottom at this side, so we're going to drop that to 6 as well, and we'll just have this tendon pull out straight at the slab edge. We want to review the next tendon. You can see that there's a very short span. If I zoom in on this span, there's a very short span that's cantilever down shape at the edge. Because there's a wall on this edge, this tendon is straight, so we're going to change this from cantilever down to straight, and we want to make the CG at the end 2.25 inches, and that will just run straight out from the top of the wall out to the slab edge. The same thing occurs on the opposite end, so we'll do the same thing there. Change that to 2.25, and we'll accept those changes. And we've input the first set of banded tendons in the model in the X direction. We'll do the same for the next set. We're going to leave the criteria as shown, and we'll select OK. And right away it tells us that there's tendons outside of the slab. So we'll double click here, go to the last span, and delete those first two regions. This tendon is still slightly outside, so if I select that and trim this tendon, it should bring that back to the face of the slab edge. And notice this tendon actually runs through the opening, so this is why it's still colored pink. If I select the tendon and grab this, I will move it over manually, and I'll just slide this over so I don't have as steep of a profile on the horizontal plane. I'll just shift that over ever so slightly, and then this one I'll shift over as well to the end of the wall. And we'll go ahead and review the profile. Again, we have a profile here that's a cantilever down, a very tiny span, and so we'll leave it as cantilever down, but we're going to anchor this at the center of the slab. And you can see now that this drops and it pulls out at the center. There's a short span here with some profile. I'm going to change that short span to straight. And we'll make the same changes here for this tendon. There's a wall at this side, so we're going to again make this this tendon 2.25, and now that's straight out over that wall. For this support line, we may want to add some straight tendons. Since we're getting close to a wall, we don't need any profile per se, but we do want to make sure that we have some pre-compression in the slab out here on these edges near the walls. So if I map this tendon, there's two ways of doing this. I could simply map the tendons to these support lines, and instead of using a cantilever down shape, we're going to use a reverse parabolic shape for each of the spans, and then we're going to just change those to straight CGs to make the tendon straight. So we'll say OK, and rather than modify this and move it in, I'm just going to simply increase the count of strands for this one tendon that's inside the slab by 2, multiply that by 2. So I'll just delete these tendons, this will become 16 strands, and we're going to change all of these spans to straight. We're going to anchor these at the center of the slab, so we'll change the CG values to 6. We've made the same change at the tendon for support line 2. We've deleted the tendon that was outside of the slab, and we've increased the count from 4 to 8 strands in this location. So notice that the shape here again is straight. So we'll go ahead and leave that. We're going to do one more banded tendon along this line. So we're going to map that banded tendon. We'll go ahead and we'll shift these tendons so that they're inside of the slab. We'll trim and extend this tendon. We'll move this tendon closer to the column support. Since we've shifted it to the slab, we just don't want as much horizontal sweep in that strand. Here we'll go to the end point of this wall, and then again we're going to shift this into the inside of the slab at the wall. We'll make sure we save those changes. And again, we have this issue where we have a reverse parabolic shape here, so we'll just make sure we change those CG values to 2.25, and this will be 9.75 from the bottom. Or we could just make this straight, and we have the 2.25 shown there. And then for this strand here, we have a similar condition where we'll make this tendon straight, modify the CG value, and we're done modifying that tendon. Now the remainder of the tendons in this direction are going to be distributed tendons from this point down, and then we're going to use banded tendons in the Y direction on this column line and on this column line. So we're going to continue here using banded or distributed tendons in the X direction. I'm going to deselect the display of the strips, and the first thing I want to do is create a master tendon. So I'm going to locate this tendon about midway between these two columns. Since this force is essentially accounted for in this tributary region, I'll come to about midway where I start my distributed tendons. I'll select the endpoint. Using my orthogonal tool, I'll map this to a line projected from the center of this column, again across to the next center point, and then I'll go perpendicular to the opposite slab edge. Because this is a distributed tendon, I need to set some properties. I'm going to be using 1/2 inch diameter strands that are unbonded. I'm going to use 3 strands per tendon bundle. The stressing is going to be effective force method. I'm going to assume a force of 26.7 kips. And my CG values, I'm going to max out the drapes for this master tendon, as we call it. And I'll go ahead and select this. You can also display stressing ends if you wish, or disregard or consider the tendon. So we're obviously going to consider this tendon. I'll close the property box, and I want to map this tendon through a range within the slab. So what I'm going to do is I'm going to use the Map Distributed Tendon tool. It's going to give me a similar box as mapping banded tendons. I want to optimize using these options, similar to a banded tendon. The master span is going to be the interior span. I'm going to enforce a placement of 8 times the slab thickness in case that controls. And notice that the tendon properties, the effective force is 26.7 kips, and the number of strands per tendon is 3 strands. So I'll select OK. The program is going to prompt me to select point 1 of 4. So this is the opposite end of my mapping range that I'm going to select this. So I'm going to again turn on my snap to endpoints. I'll say that this is going to be point 1. Point 2 will be at the column line, so point 2, point 3, and finally point 4. And the program has mapped distributed tendons throughout that region. Now if I wanted to, I could just take this tendon and I could copy one up to fill this area in here. So we'll go ahead and do that. If I open the Copy Move toolbar, we have the tendon selected. We're going to copy this up, so we're going to, in the Y direction, we're going to space this, let's say, at 3 feet. I want to copy it 1 time, and there's the copy of the tendon. And I'm going to sweep this a bit. I'm just going to bring this up slightly and follow the shape of the strand above. The next set of tendons we're going to input, because this beam has a tributary that goes about halfway between the beam and this column line, we're going to avoid putting any strands in this zone in the slab because the beam tributary covers that region. So if we are going to post tension this beam, we would just go ahead and, using the support lines as a guide, I'm going to select this support line, and I want to go ahead and map a banded tendon to this beam. So I'll use the same criteria, say OK. Again, we have tendons that are sticking outside of the slab. That's okay. We're just going to go ahead and delete one of those tendons. So we'll delete this, and we're going to use this as our one tendon. So I'll increase the count again to 6. You can see that because of the way that the support line is generated, the tendon stops at this point up here. So we want to, the first thing we'll do is go ahead and shift that down. And we're also going to shift this point down slightly on the top of that wall. The same thing with the end point. And now we'll review the shape. The shape here, we want to bring this down to a straight profile. The beam depth is 18 inches, so the depth of the offset here will be 9 inches. That allows the tendon to pull out straight on the centroid of the beam. If you want to calculate the centroid of the actual design section, you could do that. That would be a flange section, and you could pull it out at that location as well. So I'm going to modify this to 6, the CG value at the center span, and then again over the wall, this span, we want to make this straight. So we're going to go ahead, change this to straight, and we're also going to change the last span to straight and modify the CG value at the end. We'll select that, and this is going to be our distributed tendon output for this model. Now, we could also add straight tendons over this wall here in the similar way that we did at the top of the slab in this area. So we could, let's say, just dead end a tendon maybe 5 feet or so off of the end of this wall, begin there, and run this out straight to the edge of the slab. And we'll just assume 3 strands. We'll change the shape to straight, and we have some pre-compression in that zone of the slab. This will conclude the input of the strands in the X direction. So a lot of times as you go through the design process, you're required to make changes to X and or Y direction strands. So it's a good thing to group them into different groups so you can select the visibility of each group. And prior to doing that, one thing that we do want to do is we want to extend these out to the slab edge. So that's something we failed to do. Go ahead and make that change. Since it is a cantilever, here I have it just pulling out at the centroid. If we wanted to, we could have added a span and made that some reverse or a cantilever down shape or some shape associated with the cantilever. But for this model, we'll leave it as it is there. Now we'll go into the grouping. If I select Group Library, I want to add 2 different groups. So I'm going to select New. For Group 2, we're going to call this banded, or I should say, let's say this is X direction. And then for Group 3, we're going to call this Y direction. We'll make sure both are selected. Say OK. I want to grab all of the tendons in the X direction. I'll go to select or modify item properties, and I'm going to select the group X direction. And then for the Y direction, we'll make those Y direction tendons. So in this direction, we're going to have, in reality, we're going to have a banded tendon along this column line that's going to splay out into distributed tendons. And the way we can easily model that or approximate that is as follows. We're going to add a banded tendon, and we're going to map this banded tendon to the support lines. And we're going to map the banded tendon to the support lines in the Y direction. So we're going to toggle to the Y direction support lines. I'm going to turn off the display of tendons, and I want to band or map banded tendons along this line and along this line. So the first one I'll do is on the left. We can actually do both at one time. If I grab both of them, I can go ahead and map both at the same time. And you can see we're going to get the mapping as shown here. So because these spans were input top to bottom, as far as the support lines go, the tendons are going to map that way too. We don't want the spans 1, 2, 3, 4 because we want to add, we want to make sure that this tendon terminates here. So we're actually going to keep span 4. We don't want spans 1, 2, and 3 from the end. So we're going to go back to this location, last span. We're going to delete the last 3 spans, and I'll go ahead and close that. We're going to do the same for the tendon here. We're going to delete those last 3 spans. And in this case, we have 1, 2, 3, 4, 5 spans that we want to delete. So I'll go to last span, and we've deleted those. Doing the same here, we'll delete the last 5 spans. And before we go in and modify the tendons, we just want to make sure we trim these back. So on this tendon, we're going to delete the first span, which is this one outside of the slab region. Just delete that. And on this one, we're going to delete again the first span. And now we can go into modifying the strands as we want them. So for this tendon, we're going to go to Shape System Friction. We're going to call this a cantilever down shape because this is going to terminate over the top of the column. The CG will be 6 inches from the top. And we're going to shift that CG at some distance off of this column. So I'm just estimating this at 5 feet or so. We're going to do the same for this tendon. We'll bring this to the same point. This tendon will be cantilevered down. Notice that the end span on this tendon is a reverse parabolic shape, but in reality it's overhanging a beam. So we want to slide this CG over to the center of that beam, and we're going to make that also a cantilever down shape on the exterior. And we'll center this again at the centroid of the beam, or the centroid of the slab. We'll do the same thing for these tendons. We'll change the far end also to cantilever down. And again, this span is going to be slid down to the center of that beam. We're going to bring this to this location. And we have a little bit of profile here for this tendon. This is probably too much profile for that short span, so we can adjust the CG value at this span, let's say to 10 inches or 9.75 inches to make that straight. We could drop that also if we wanted to, so we might make this 6 like so. Just checking this strand, we have 2 cantilever downs on both sides. So these tendons in the banded direction have now been input. Now, because we have a count of 8 times 2, so we have 16 strands in this tendon. These 16 strands are going to splay out in reality, so we want to make sure that we have around 16 tendons from this location over to this location in the mapping, because those 16 are again going to splay out in both both bands. We'll go ahead and turn off the display of the support lines. And again, as we did in the X direction, we're going to begin with inputting the tendons in this zone where these two banded tendons are. We're just going to overlap them from the tail of this tendon or from the column line. So I'll start at this location, and this is going to become a master tendon, so I want to turn on my snap to perpendicular. Turn that off, and I'll make sure I snap to the perpendicular to the edge of the slab. The master strand is going to have 3 tendons, and if we know we want 16 tendons, we could do something like 4 tendons, and we could just evenly space these in between this zone. So that's likely what we'll do in this case. So we'll have 4 strands with some given shape. The back span is going to be off of that column line, will be a cantilever down shape again, anchored at 6 inches from the top, and we'll leave the profile set as it is. Now we can dimension that support line, so if I toggle to the Y direction, I might move this over to the boundary of that design strip. It doesn't need to be at the boundary, but just for the sake of getting even spacing, if I have 4 groupings of tendons through here, I'm going to just take an average dimension. If I create a dimension line from this point to somewhere in here, it's around 24 feet. So I want 5 divisions in 24 feet, and we're going to space those tendons at 4.8 feet on center. So I'll go ahead and grab this tendon, I'll go to the copy move. In the X direction, we're going to say this is 4.8. I want 3 copies, and I'll copy that through. So the division I calculated was incorrect. It's actually going to be 3 divisions, so if I go 24 over 3, I get 8 feet. We're going to go ahead and do that one more time. This is going to be 8, 3 divisions, copy that, and now we have the banded tendons in, or the distributed tendons in this zone that might be essentially splayed out from these bands in an actual construction of this slab. So if we wanted to, we could take these and actually shift them over so they're closer to the location where they're going to be originating from. We could do something like this. Or we could actually bring them all the way over to that point. So this is a decent approximation of what we're trying to accomplish with this. So I'll just move this last one over ever so slightly, and move this one in as well. And now we have those strands. And we also want to do the same thing for the next zone. So I'm going to again assume 4 strands, and I'm just going to manually input these tendons. So the first grouping might begin at this location. It'll be centered on this column line. And because we have a wall here, I'm going to just bring this up essentially even with that support line to the next wall, to the next column line, and then to the slab edge. And we could go back to snap to perpendicular, and that's our first tendon. Now the second tendon will be similar to this. And again, snap perpendicular to the wall. We'll do the next tendon directly on the column line. We'll turn off the snap to nearest and just snap to the midpoints of the wall. This tendon I'm going to run over the top of this wall. And I'll end here at this location. If we double click, we have 4 strands, and now we can modify the shapes of each of the strands. So we'll do this as a cantilever down shape, and we go right into our profile. Because the CG is just mapping the maximum CGs entered in criteria, we need to adjust some of these just using experience. So this CG might be raised up slightly, let's say 4. The next CG might be raised up to 6.5, and so on. So we'll go ahead and modify that and the remainder of those tendons. As we approach or get closer to this wall, we're actually going to modify this shape to a straight tendon. So I just caught that in the model. If we take this and make this straight, it's a span over, so we'll change that back, go to straight in the third span, and we'll modify that back to 4. We'll do the same for these strands here. So the first shape is going to be cantilever down. The span 3 will be straight. And now we have those distributed tendons that would come out of these banded tendons. The next part is going to be, just to complete the Y direction tendons, is to map tendons in this zone and also over here in this zone. So we want to create a master tendon to begin, and as we get closer and closer to this wall, this tendon is going to become straight along this span and also partially along the second span. So the first thing I'll do is just simply map a distributed tendon away from the wall near this column line. And so I might map it directly on the column line. Turning off snap to, or snapping orthogonal, I'll do snap to perpendicular, and this is now my master tendon for this zone. So here I'll change this back to 3. We could use 4 just to remain consistent with these tendons here, but I'll switch it to 3 just by way of example, or for the sake of the example. And we have the profile that we want. We might raise this up slightly on this end, so this might become 4, and this is now our master strand. So we're going to map this strand over some distance. So I'll select that. I'll map distributed tendons again, use the same criteria, and we're going to map this over a distance to right around this location here on this, just to the left of this wall. So I'll go ahead and select my points for mapping, and these are the distributed tendons that have been mapped. Now, because I have banded tendons here, I might also have a few straight tendons running the length of the slab here. So I'm going to just input those manually. I'll start a tendon here that's going to run the length of this wall. It'll be straight, and then it might go into some profile parabolic shapes there. So I'll run 2 sets of banded tendons, or of uniform tendons. Span 1 again will be straight, so I'll modify that. At the top of the wall, and then it runs into this profiled shape. As we draw closer to this wall, I want to input these tendons manually. So I'm going to go ahead and begin by just inputting in the straight strand that's going to dead end at this wall, and I'll space those maybe 2 in this division. So selecting again at the bottom of the slab, run that over the wall, and then perpendicular here. The next tendon I'm going to make is going to be, since I'm getting closer to this column, I'm actually going to start having some type of a profile. So I'm going to select here, and then opposite wall, and the end of that wall. And now I'm getting closer to this column, so finally I'm going to have a similar shape. This will be 1 span, and then the final span here. So at this tendon, the first span will be straight, the last span is also going to be straight, and as we get closer to this column, we have 3 spans. So now we're going to retain the shape for each of the spans, but we're going to lift the CG since we are closer to this in a slab area where we have some stiffness from this wall. So I may not profile the tendon as much in the outer spans, especially this shorter span on the opposite side. I might raise that to something like 5.5 inches, or some other good starting point for that span. We're going to have a similar condition on the opposite side, so we're going to create our master tendon again, and the master tendon, let's say we'll start at that corner of that slab edge. We're going to run it to the column and then out to the edge of the slab. I'll select that and trim that. On this far end, this is going to be a cantilever down shape, given that it's a cantilever off of that wall. So we'll keep that shape for this tendon, and then we're going to map that over some distance. So we'll go back to the map distributed tendon, select the input, and again I'll just go to the right of this wall. My second point will be here. My third point is going to be that I'm going to create the next point at the center of the wall and then at the center at the edge of the slab. Because we have this cantilever, there's a very short span on these mapped tendons, and you can see that that's going to grow as we go near the master tendon. So here we can just simply stretch this out, and on these other tendons we're going to have to bring this back in towards the slab edge. So I can just select that and trim that. We want to make sure that those are the proper profile at this end. So we'll go back to 6 inches. And then at this end we'll make that 6. So it's centered at the center of the centroid of the slab. These are cantilever down shapes at the cantilever. I'm going to copy this one time to the right. I'll just say it's 3 feet. Let's go ahead and input this manually. It wasn't copying there, so we'll go ahead and just select our points again. As we get closer and closer to the wall now, we're going to go ahead and we're going to change that to a straight profile. So we'll put in 2 more tendons, and we'll do one right on top of the wall. On the opposite end, we want to make this cantilever down shape, and then we might start to raise the CG or actually just make these 2 end spans straight along the length of the wall. Okay, and then the final area that we're going to work on is maybe a couple of straight tendons similar to this side. We're going to start out here near the wall. We'll run that towards the full length of the wall. We'll do one more strand here. And then we might dead end a tendon here inside of at the face of the opening and run this to the exterior of the slab. We'll leave that as it is. This one we're going to change this first span to straight, and we could modify again the CG values of those other spans. The reason being is we're not mapping anything. The program isn't calculating any optimized tendon profile or force, so we're simply making educated guesses on the profile and also the required number of strands in this case. And that may require you to make some manual calculation on what the force needs to be over some unit tributary of 3 feet or 4 feet or some distance. So and typically if you take a mapped area like here where the program actually mapped it, you could take this and you could determine how many what the spacing is between these strands and apply it to those areas that might need to be manual input. So the tendon input and the tendons in the X and the Y direction are complete. We're going to now select the tendons in the Y direction, and we're going to just group those as Y direction tendons. So we'll go back to modify item properties and we'll select Y direction here. We're now ready to run the analysis for the model and go into the support line results toolbar to show how to graphically review the stresses for each of the support lines with respect to the post-tensioning. We're going to go to FEM. We want to mesh the structure. We can see that this mesh begins to get very dense as we get near this edge of the slab. So if we go ahead and turn off the display of the mesh, this may be a situation where we want to idealize some portion of the slab. And in this case, we have a wall that that steps in. It's flush on the inside, and due to this step and the way the program is delineating the slab and meshing the slab, we have that really tight, densely spaced sparse mesh kind of leading to this edge. So one way we could modify this is I'm going to select the slab edge. I'm going to delete one of the points. I'll then use a line as a construction line and use the orthogonal tool on the snap toolbar, and I'll shift this slab edge to this location. And we're going to want to shift the wall so that it's in line. So this is not going to significantly affect the results in any way. We just want to do this in order to reduce the mesh, essentially the cell size and the number of nodes, and this will allow for faster computation time. So using construction lines, we can go ahead and relocate this wall. So we have the wall located here. We can use the modeling toolbar to move the wall, or we can just simply take the wall. It's an 8-inch wall, and we can shift it to the right using the copy move toolbar. In the X direction, this will be 0.33 feet, and we'll just move that wall that dimension. So we've relocated the wall. We'll go back to mesh. And now we get a much more evenly spaced mesh. So this is a way to modify the slab in order to get a nicer and a more evenly spaced mesh. We're going to go ahead and go FEM, Analyze Structure. And while this is analyzing, it's important to note that we don't have to change this mesh or modify the region. We could have gone ahead and analyzed that slab. But again, in order to make a slight modification to get a faster computation time with essentially the same results, this is something we can do within the geometry and the modeling of that in the slab. The analysis has been completed. Before we go into the design of the sections, it's important to just make some validation of the analysis results. So I'll go to the FEM viewer. In viewer, I just want to modify, or I just want to check for one of the load combinations, just the deflected shape. So for service total load, we'll go to deformation and review those results, just the deformed shape, and make sure that this deformed shape intuitively makes sense with relative to the span length and the location of support. So just by reviewing this helps us locate any problems that might be associated with the modeling. This deflected shape looks correct, so we're going to go ahead and close that. Once the analysis has been completed, we're going to go to FEM. We've already generated the design sections, so we're going to go right into the design of the sections. And this is where the program will design reinforcing and also calculate stresses and actions at the different design sections. So for this video tutorial, we're specifically focused on reviewing results for the stresses due to post-tensioning at the design sections. Once the sections have been completed, we'll go ahead and select yes. And we're going to turn off the display of the mesh. I'm also going to turn off the display of the tendons for the time being. And I want to view the support line results toolbar. And we're going to select the X direction or the Y direction support lines using this toggle bar here. So the first thing that's noticeable is the section is either green or pink. Green section means that for the service envelope of stresses, the section satisfies the allowable stress. In the criteria general tab under allowable stress, our allowable tensile stress for sustained and total load is 6 root F prime C, and for the compression and compression at the sustained load and total load conditions, it's 0.45 times F prime C and 0.6. So those are our allowable stresses set in the criteria. And if we look into the results a bit deeper, we can go to the result display settings from the support line results toolbar. And here we have envelope selected, so I want to go ahead and switch this to service total, and I'll say apply. And now we can look at the top or the bottom stress graphically. We'll select bottom first. When we select bottom, we can display these graphically, and if I select 1, 2, 3, all of the values for each support line will be displayed. This may require that you modify the font size of the text, so I'll modify this to 8 inches. Select OK, and now if I zoom in, I can see the different stress values at each of the design sections. So where it's pink, these are where we want to focus on at least meeting the allowable stress. If we want to optimize a slab, then that would require us to make a good thorough investigation of the different stress levels for each of the spans and determining if we can reduce or eliminate tendons or reposition them in a way that's more efficient for the constructability of the slab. In this case, we're just focusing on the overstressed region, so we can see right away that here we're at a level of 431.9 psi. If we review the tendons in this region, these are distributed tendons, and the drape here is 2.25 inches. So in order to correct this, we might have to drop the tendon slightly more if possible, with respect to cover and maintaining the proper cover for the reinforcing and how those layer against one another. We have 3 strands, so we could obviously add additional strands so long as our maximum precompression isn't exceeded, leading to an uneconomical design. So that's one way to resolve issues for overstress in a slab. If I go to average stress and I say apply, this will show us what the average stress is for that design section. So my average precompression in this zone is only about between 119 and 130 psi. So right away we would have to add tendons here just to maintain minimum precompression, which would likely resolve the issue of the overstress at that location. that's the first thing that we would do in order to resolve that. So we may have to increase the count of tendons in this direction by 1. So instead of using 3, we might change these tendons to 4. So we would make a thorough review of all of the different spans for stresses, average precompression, and balance loading. And then again, that can be done graphically from the support line results toolbar. We can also make that check using builder sum. If I go and toggle to this direction, again we're showing precompression on the screen. This span is obviously under 125, so again we would have to modify the count. We might change this from 8 to 10 tendons in order to get the proper precompression in the slab. And part of this may be due to the fact that the force envelope may have been dictated by some other span meeting that precompression, or there might be some location where there's restraint of walls, which is causing the precompression to be lost in the slab. So there may be several factors that influence the level of post-tensioning or the level of precompression in the slab, which would then need to be modified. If I go back to stress, again this will toggle to the different stress values. So along this line we can see that the stress is satisfied in these bottom zones until we get to this longer span, and now again we have an issue where we're overstressed, and that would need to be rectified. The alternate way again is looking at this through builder sum. If I double click on a support line and I select the builder sum tab, the program will open the builder sum module, which would allow me again to select any of the load combinations. I'll select service total load, and I'll select the stress diagrams. The stress diagrams will allow you to plot the top stress versus the allowable, and we can see here that our top stress is exceeding the allowable, where our stress is 489.7 psi. And we can also review the bottom stress versus allowable. So we have one area where that exceeds the allowable stress. Again, we're at 484 psi. We can also review the average precompression. We have a fairly significant increase or bump in precompression somewhere near the middle of this span. If we go back to the precompression output, we could likely see that same bump in the slab again at this location here. And the reason we have this bump is if we select the tendons, we have tendons that are overlapping one another in that region, so there's an increase in the precompression due to that overlap. In reviewing the results either through builder sum or through the graphical display, once the stresses are satisfied, the precompression satisfied, and the balance loading is within a range satisfactory to your design, the design would continue in reviewing and generating the reinforcement for the slab. This will conclude this video tutorial on the generation of support lines and tendon input for FloorPro 2010.